Hello and welcome to the second part of Modo rendering tutorial. In the first section of the tutorial we discussed rendering passes and rendering settings inside of Modo. In this section I would like to show you cameras, lights and materials. We will also look at the way you can output multi-layered or multi-channel images from outside of Modo for compositing inside of a compositing application such as Nuke. So have fun and enjoy. Cameras can be easily identified inside of the 3D viewport by their 3D icon, and also they can be found in the item list where they're represented by a little icon, a camera icon next to the item itself. Cameras inside of Modo function in a similar way to a real-world camera. You can simply grab the camera object, adjust its position, move it anywhere in your scene, rotate it around, and adjust what your camera is currently looking at. To further enhance the direct link between the virtual cameras and the real-world camera, you can also set the sensor size or the film bag directly on the camera item. So with the camera item selected, I can choose, for example, full-frame DSLR sensor, 4/3 DSLR sensor, and various types that are available from this list. You can of course set this also manually. Modo will not only set the proper angle of view corresponding to the given focal length, but also it will change the aspect ratio of your frame on the render item to match with the given sensor size. Aside from the sensor size, also other parameters that correspond to the real world can be found on the camera item. Parameters such as the focal length, where you can quickly change the type of lens you are using for your image. And another interesting feature is that you can directly on the lens itself adjust the curvature or the distortion that the lens will receive. You can greatly exaggerate the effect for artistic purposes or create something more subtle to enhance the realism. Another set of physically based effects such as the depth of field and motion blur can be found under the Camera Effects tab. Just by enabling the depth of field checkbox, I will get beautiful bokeh effects in my renders. It's worth mentioning that if you keep your scenes at a realistic scale, all the numbers such as the f-stop number and the distances and the lens will work together to give you really realistic results. So let's say I'm using right now a lens with 1.2 f-stops, but I can quickly change it to, let's say, 3.5, capturing less light, thus giving me much more sharper image. I can increase it or decrease it at will. All these numbers could really correspond to real-world lens parameters. Another great setting that helps you to sell the motion inside of your virtual studio would be the motion blur setting that can be enabled on the camera. So if I enable this, not much will happen because this particular setting has to be also enabled inside of the preview window. So if with the preview window enabled, you'll see that all the little bones that are actually currently in motion are being blurred. So all these tools and settings combined together allow you to really work like a real-world photographer with the proper tools that you expect from a high-quality real-world camera. The FX tab is also a place where you can find your stereoscopic settings. Here you can enable and disable your stereoscopic renders. You can adjust distance between the eyes and all the parameters related to stereoscopic rendering. Then once you hit the F9 for the final render, Modo will process the image twice and give you the proper stereoscopic display that you've chosen. In this case I'm using side by side. Aside from the standard perspective camera inside of Modo, you have access to different types of cameras that allows you to generate orthographic images, cylindrical images or spherical images. So for example, when you need to capture the environment of your scene, you can use a spherical camera and you can render a perfect solution for your image-based lighting, or you can create a reflection sphere to use in different scenes. When you're creating illustration or an awesome game art, you can use orthographic camera to create a specific look. When it's time for the render, you can choose which camera will be rendered on the render item. The interesting thing to note is that this is animatable as well. Great, so now that we know how the camera in Modo operates, let's look at the other vital component of the renders inside of Modo, and that is lights. As you can see from this list, there is quite a selection of possible options that you have when it comes to lights. And most of them do share common properties, and they all operate in a similar fashion. So now let's have a look at the lights in more detail. If I just go ahead and enable my directional light in the scene, we'll see I'll immediately get a feedback inside of the render preview, and also the icon inside of the scene representing the light will be visible. From here I can go ahead and start adjusting one of the common properties, such as the radiant exitance, to adjust the intensity of the light directly, and the preview will be able to keep up with me on fly. While the physical properties of the light, such as the intensity, can be adjusted on the item itself, color properties and shading related properties of the light can be changed on the light material within the shading context. Here you can change the color of the light, you can even set the temperature based on a Kelvin scale, and you can also include the texturing and light gels that will multiply or add to your overall lighting, giving you quite a few options how you can actually perform the shading operations. So now let's have a deeper look at the properties of the directional light. So directional light can be used to simulate a light from a light source where the light travels in one direction. For example, sun would be a good example, moon and light sources of that nature. And probably the most unique settings, aside from the physical sun property, which we'll discuss in further detail a little bit later, is the spread angle. That allows you to control the angle at which your shadows will be spreading. So if I set this to a fairly high number, like 15, you'll see that I'm getting much softer shadowing on my object. Another extremely useful light type inside of Modo is the area light that allows you to simulate lighting objects such as studio lights, softboxes, and objects of that nature. It can have two shapes, the rectangle and ellipse, and in both cases you can set width and height of the light. One of the great things that I particularly like about the light is that it can be visible to camera, and it can also show in your reflections and refractions as a true light source, unlike the directional light, for example. Interesting thing to mention while working with the area lights is that just by adjusting the size of the light, you'll be getting completely different types of shadows. So of course, when you make the light smaller, generating sharper point, you'll get much sharper shadows on your objects. When it comes to adding drama to your renders, Spotlight is a perfect candidate for this. It allows you to emit light in a similar fashion to a flashlight or a beam, where you can control the cone angle and soft edge of the beam, achieving quite dramatic, focused, and perfectly directed results. Adding lights to a specific location and simulating objects such as light bulb, for example, can be easily done by adding a point light into your scenes. Another great light that can enhance the realism of your scenes is a photometric light. Photometric lights are using predefined profiles or captured profiles of lighting, such as these. These accurate measurings can be downloaded from quite a few lighting manufacturers' websites for your use. And the great thing about them is that they are giving you all the nuances and the fine detail that was actually captured. So the light is not uniform and it gives you much more realistic render. The last light that I would like to show you before we move on to the global illumination renders is the dome light. It allows you to quickly simulate the global illumination look and cover your scene with light without going through the whole global illumination renders. So now we had a look at the individual lights, sort of one by one, but of course they work best when they are combined together to create unique and beautiful lighting environments for your scenes. So now let's move ahead and look at the global illumination related lighting. First topic that I would like to discuss within this global illumination context would be the geometry-based lighting, or so-called lumigons. They sort of lie in between the HDRI world and lights world. To take advantage of this technique, we need to enable the global illumination inside of your scenes. So to do so, let's just go to the render item and enable the global illumination setting. I will just reduce the rays to increase the speed. And also I'll make sure that my global illumination is also enabled within the preview. Great, so now I'm ready actually to enable my Lumigon and see the result of this operation. So Lumigons are really just a massive geometry, and you control them via the shaders that have the luminous intensity set to a certain number higher than 0. They will cause them to emit light and influence your scenes in a similar way to area light, but within the global illumination context. Since this is a material-based technique, Any piece of geometry that has a luminous material applied to it can become a lumigon and can emit light into your scene. This makes them perfect candidates to be used when you need lights that have unusual shapes and you need to create lighting effects from those objects. If you're interested how to create and assign materials, we'll cover this topic in a second portion of this tutorial. One of the great tools in your arsenal when it comes to global illumination lighting is Modo's Sun and Sky or Physical Sun and Sky system. To use it, go to your environment material, choose Physical Based Daylight from the drop-down menu, enable the direction light that is associated with the physical sky as a sun object, and with only a few clicks of a button you have now available a solution that can be adjusted for different times of day and different lighting scenarios. For the ultimate realism or a perfect blend between a generated imagery or background photography, you can use image-based lighting inside of Modo. To accomplish this, all you have to do is just load up an environment or drop an image into the environment and enable global illumination. And Modo will give you a lighting solution that will match your background image every time. One of the greatest additions to Modo's image-based lighting toolkit was the environment importance sampling that allows you to achieve sharp shadows with your images with the decreased render time and improving the overall quality of your renders. As a side note, I would like to mention that you can find excellent lighting kits based on CGRiver on the Foundry website. They're all based on high quality imagery and they're excellent starting point for your render. Excellent, so this concludes part 1 of this tutorial where we had a look at the lights and the cameras inside of Modo. Please feel free to join me for the second part of this tutorial where we will have a look at the materials and the way we can output the channels for compositing applications such as Nuke. So have fun modeling!